Okay, so we're looking at the Hardy-Weinberg equilibrium situations, and those are situations where there is no evolution. So every allele has an equal opportunity as every other allele to succeed. So to have that, Hardy-Weinberg, they put together their premises. They said, no natural selection, no sexual selection, no one leaves, no one comes in, no accidental loss, also known as genetic drift. So you take away all these conditions, which doesn't happen in the real world, and then you have a Hardy-Weinberg equilibrium. And they put out this equation. So their equation for the equilibrium situation is p squared plus 2p cubed plus q squared equals 1, where p is the variable that represents the dominant allele, and of course p squared would be the homozygous dominant condition, 2pq would be the heterozygous condition, and q squared would be the homozygous recessive condition. So for example, p squared, if big B was for black fur, it was dominant, and little b was white fur, it was recessive, then p squared, for example, would be like big B. And then 2pq, it would be big B, little b for the pq, and then q squared, of course, would be 2 recessive, so that would be q squared. The other equation that goes into that is the one that says p, which is the dominant allele, plus q, which we say is the recessive allele, equals 1. Because if you have all of the p's and all the q's, you have all the alleles, and 1 is the probability, which means 100% certainty, p plus q equals 1. So that's how that goes. Let's try to work a situation. So let's say you have a problem on the AP test, and it says something like, you have a guinea pig population, and let's say 75% of them are black, and that's all you know. So use your deductive reasoning. If 75 are black, what is the only other possible color? They come in black and white. 75 are black. So right off, and let's see if I have a different color. I don't. Oh yeah, I do. So you know right off the bat that the remaining 25% are white. You were not given that, but you're able to deduce that from that situation. So now you know that 25% are white, 75% are black. Don't work with your dominant allele, because there's 2 ways to be black. You could be black here, you could be black here. You don't know which it is, so there's no way to allocate percentages to the black. But you can allocate percentages to the white, because you know the only way to be white is right there, q squared. So you know now that q squared equals 25%, which 25 over 100 is 0.25. So now you know q, because if you know q squared, q is simply q equals the square root of 0.25. So you take out your handy calculator, which mine is not here. Who's got a calculator can do that for me? Can you square root 0.25, square root function? Somebody else double check it, just so we're sure. And it's how much? 0.5? Oh, that makes sense, yeah. 0.5, what am I saying? It's 25, yeah. So q equals 0.5. So I'm going to use the blue ink. So now I know q. And once I know q, I know p, because if q is 0.5, what is p? P plus q is 1, so of course it's 0.5 as well. So now I know these two, I can figure out anything. So you go back again. Do not use your dominant phenotype. Use your recessive to come up with q squared, and then work your way to the square root to figure out what q is. Once you have q, you have p. So we're good with that. We have p, we have q. Now, no matter what you're asked, let's say they ask you, what percent of the population is homozygous dominant? So homozygous dominant is p squared. So p squared equals, you just go to your p, 0.5 squared, which is going to be equal to 0.25, which is equal to 25% of my population. It's that easy. Once you have p and q, you have it all. What percent of my population is heterozygous? Okay, it's 2pq. So it's 2 times p, which we said was 0.5, in this case they're equal, times q. And so 2 times 0.5 times 0.5, so that's, we said 0.25 times 2, so we'll come back to 0.5, or equals 50%. So 50% of 2pq, and then q squared would be the same as that, so it's 25%. The main thing I want to emphasize is find q squared first if you're given the phenotype. If I can find my phenotype for my homozygous recessive, I know my q squared, so that's step number one. This gives me this. Using a square root function, I have q and I have p. Once I have p and q, I can plug it into this and find any of the conditions. And so good luck on your AP test, and thank you for watching this amazing video. Thank you, Elijah, for